Internal structure we can able to see, and for FESAM we can see the surface morphology and topography of the sample, right? So similarly we can TEM we are using, we can know that elemental composition of the samples as well as mapping also we can able to do it, right? So here also we can able to do the same funda. We can see the elemental composition, ADS, and as well as mapping also. Okay, so what is the difference between these two instruments? You know it, right? Right? Internal structure, if we want to see transmission, only the outer surface, scanning electron microscopy. Okay. Actually, for a TEM, we want to go with a little bit more like the sample should be in a liquid form, and the sample should be, if it is a biological samples, we should make an sectioning for the tissues or something. For that we want to go for ultra microtome and all these things, right? So little bit having a more steps and very little bit tricky, right? But for scanning electron microscopy it is not like that. If you have a film, you can see it. If you have in a powder form, that also we can see it. If it is in a solution form, that is also we can see it, right? And if it is a biological sample, that is also we can able to see without doing any more steps like a sectioning and whatever the things. But if the condition is only the sample should be made dry, because the system is working under 10 to the power of -8 Pascal, so we should the samples make a very dry form. If the sample will not make a dry, then you will not get the image properly. So the main thing is the sample preparation. So if your sample is, you all belongs to which department? Chemistry?
Pharmacy.
Zoology, biological, right? Mostly biological? Nanoscience? Now material science also. Okay. So for material science also, for biological sample also, whatever the sample should be dry. And the sample preparation is very important. And after the preparation also, how you preserve your sample, that is also very important. For example, tomorrow you want to do the FESAM, right? For but yesterday evening you finish the sample, you process the final samples. Okay, then you leave it as it is in a lab. You should not go like that. You should be protect your sample. You should be save in a place in a sample in a like ovam or vacuum desiccator or any refrigerator. So wherever your sample is keeping in a constant level, then you should be preserve that samples. Okay. So different types of samples also we can able to analyze in this instrument. And if the sample is non-conductive material, we can make it as a conductive material by using sputter coating. Okay, here we are using two types of sputter. Like the sputter machine is one, and we can have two types of methods. One is platinum and another one is gold. If here we are mostly in this lab we are having two types of instruments. One is micron level and another one is nano level. This is nano level instrument. This is field emission gun scanning electron microscopy, FEGSEM. Okay, this giving a nano range level, and another one is tungsten filament, and that is giving that micron level samples. Okay, micron level images. For example, for 2000 magnification I want to see my samples, you can go with that. Like a dental samples, you can go with that micron level range. Okay, so for any nano materials and for bigger 500 nanometer, if the sample is like a 500 nanometer particles, you can see this one. You can utilize this instrument. Okay, and here we are doing a platinum coating as well as gold coating also, but here we are using a nano. Basically, mainly we are analyzing a nano materials, so we are using platinum coating. It give more higher resolutions than gold coating. Okay, because the nanoparticles of this gold particle is very high than the platinum. Okay, so this is the main thing. And elemental composition also we can find it out how much percentage present in the sample for all the elements. Okay, so as well as mapping where the elements is present here. Like for example, in red color it should be a what is that? Aluminium. Red color is present as an aluminium. Aluminium is present here only, and that nickel is green color. Okay, so in that way we can prove that my deposition is present like in this way. Okay, so these are the images of this FESAM. For 200 nanometer up to 50 above 50 nanometer, the image will become very nice. Okay, but the sample should be in a very, yes, okay. The sample should be dry, then you can do the samples and you will get the images like this. Okay. Any queries?
So we can't get the image of carbon rods less than 10 mm.
Carbon rods. We can able to see, but we can't.